We're going to have a look at factors, primes, and multiples today. So firstly, what is a factor? And a factor is a number, obviously. So a factor is a number which divides exactly into another. So we often talk about factors of numbers. So say the factors of 15. So the factors of 15 are numbers that will divide into 15 exactly. So 15 divided by 1 will give us 15. 15 divided by 2 does not work. So 15 divided by 3 is equal to 5. 15 divided by 5 is equal to 3. And the last one is 15. So the divisors of 15 are the factors of 15 are 1, 3, 5, and 15. So factors of 15 equals the set of 1, 3, 5, 5 and 15. So they're all the numbers that go in without any remainder or without any decimal happening. Let's do 12 as well. So 12 divided by 1, we get 12. 12 divided by 2, we get 6. 3 goes in, we get 4. 4 goes in, and we get 3. 6 goes in, we get 2. And 12 goes in, we get 1. So then the factors of 12 are the set 1, 2, 3, 4, 6, and 12. So one little thing that you might notice if you like patterns is that the numbers here mirror each other exactly. So 1, 1, 12, 12, 2, 2, 6, 6, 3, 3, 4, 4. So they flip around, they go backwards. It's just a nice pattern to notice and might help you when you're doing this so that you don't miss out on any factors. So now that we have that, you can think of a thing called the highest common factor. So the highest common factor, or HCF. The highest common factor of two numbers is the highest common one of these numbers that we have in both of these sets. So we've already worked out the two sets, and now we just need to look for what's the biggest one in both, and 3 here is the biggest in both. So the HCF of 15 and 12 is 3. So that's pretty straightforward. Now we'll move on to looking at what a prime number is. So primes. Alright, do a new title. Prime numbers. A prime number, it's a number that has exactly 2 factors. And those factors are 1 and itself. So first key thing to note is 1 is not a prime number because it has to have 2 factors and 1 only has 1 factor. It's just 1. Next thing, so it obviously they start at 2 because 2 has what factors? I'm going to do them out like this. So 2 has 2 factors as 2 and 1. 3 has 2 factors, 3 and 1. 5 has 2 factors, 5 and 1. 7 is the next one, 7 and 1, and so on and so on and so on. So it gets it keeps going for ever and ever and ever, and they're really important numbers. Composite numbers then. So let me just write this: composite numbers. They're just numbers that aren't prime. Numbers that are not prime. It's just every other number that we have, which is most numbers really, because there's not as many primes as there are composite numbers. Let's have a little look at prime factors then. So prime factors is going to help us out with finding out some properties of numbers. So let's just take the example of the number 420. Okay. So 420. how do we find the prime factors of 420? First thing you do is divide our first prime number in, which is 2. Always divide 2 in first. 420 divided by 2, you're going to get 210. Okay. Then you keep dividing 2 in until you can't divide 2 in anymore. So can we divide 2 into 210? Yeah, we can. We get 105. Can we divide 2 into 105 evenly? 105 divided by 2? No, we can't. So now we have to move to our next prime number. And our next prime number is 3. And we try that, and it works out. So we can put 3 in, and we get 35. Next one again, we can try 3 again. It doesn't work. Next prime number is 5, and 5 works. We get 7. And the next prime number that'll go into 7 is itself 7, and we get 1. And then you stop. So the prime factors of 420 are 2 times 2 times 3 times 5 times 7. Which, if you multiply all them together, 2 times 2 times 3 times 5 times 7 is 420. So that's how you find the prime factors of a number, and that will become really important in just a few minutes when we find a really quick way of finding the highest common factor, and another thing called the lowest common multiple, which is what we're going to look at now. So multiples. What is a multiple? A multiple is just a number. It's kind of the opposite of the divisor thing. It's a number that's that the first number can divide into. So say the multiples of 3 are all numbers that 3 can divide into evenly, exactly. The multiples of 5 are numbers that 5 can divide into, exactly. So let's say the multiples of 3 are going to be 3, 6, 9, 12, 15, 18, and they keep going on and on and on and on and on. Multiples of 5, 5, 10, 15, 20, 25, so on, so on, so on. But then we can find a thing called the lowest common multiple. Lowest common multiple, or the LCM. And that's when we're finding the lowest common multiple of 2 or more numbers. We're finding the lowest number that both of them, the lowest multiple of both of these two numbers. So it's like the highest common factor kind of thing. It's very easy to do. If we were looking for the lowest common multiple of 3 and 5, we just go along the line and see where's the first number that are in both of these lines. And the first number that I see is 15, so that's the lowest common multiple. So I'll just circle that in red. Lowest common multiple, 15, for that one. So let's now use our prime factors to be able to find our lowest common multiple and our highest common factor. So say we have the numbers 20 and 48. Okay. And we've been asked to find the highest common factor and lowest common multiple. We could do this all by just doing prime factors. So let's prime factorize them both first and forget about any of the other stuff. So the prime factorization of 20, sorry, that's very small. 2 goes in first and we get 10. 2 goes in again, we get 5, and 5 will go in and we get 1 and we can stop. So here we have 2, 2, 5. And over here we have 48, so 2 will go in and we get 24. 2 will go in, we get 12. 2 will go in, we get 6. 2 will go in, we get 3. And 3 will go in and we get 1. So this will be 2 times 2 times 2 times 2 times 3. Okay, so that's pretty straightforward. To find the highest common factor, you take out the common prime factors. So I find the easiest way to do this is look over here and go, we have a 2 here, do we have a 2 here? Yeah, we do. We have another 2, do we have another 2? Yeah, we have a 5, oh, we stop. So we've got 2 2s and we've got 2 2s. There's nothing else common there. So the highest common factor is equal to 2 times 2, which is equal to 4. So there's the highest common factor. And then the lowest common multiple is, we write down this again. So we write down this 2 by 2. And then we write all the ones that we didn't use. So the one thing you have to be careful of is you're not repeating those 2 2s. So you have to get rid of them and then you multiply by 5. and you get rid of the 2's here, and you multiply by 2, 2, 2, and 3. And you should get 240 as being your lowest common multiple. So the reason why we do this method, rather than going through all the multiples, is that could take forever. If you were looking for the lowest common multiple and it's 240, you'd take a long time trying to find that between these. Whereas this method is really, really quick. So for highest common factor, you find the 2 common ones, or however many common ones there are, multiply them. And then the lowest common multiple is the common ones and all the extra ones multiplied on.